Today we are going to start with the new topic, that is the ionic equilibrium, right? As we have done the chemical equilibrium and you are much familiar about the equilibrium, what actually it is. You know, it is just a stage in a chemical reaction at which we get to see the constancy in the properties, right? That means the rate of backward reaction becomes equal to the rate of the forward reaction. You know that, right? Now we are just going to study about the ionic equilibrium. That means the equilibrium can be established between the ions as well, right? So before we do that, I am just giving you the introduction of the ionic equilibrium. So here I start. So you know that the chemical reactions that occur in a solution form, like, or you can say especially the aqueous solution reactions, like that means the reaction that are taking place where the solvent is present, right? They play an important role, right? So for example, see, if I take an example and I tell you there is you can say the ionic compound when in an aqueous state, like for example NaCl in water, right? So I am taking an example where I have NaCl in water. So what I get to see in it, that when NaCl is dissolved in water, or I can say the aqueous solution of NaCl is a good conductor of electricity. It just allows the electricity to pass through it. So I say it is a good conductor of electricity, right? And wherever I see few more substances like sugar in water, what happened in this case? This is again is the aqueous solution of sugar, but this is the poor conductor of electricity. So why there is a difference? As I've told you, the aqueous solutions are those solutions which contain, in which the substance is present in a solvent, right? The solvent can be water. If I'm using the word aqueous, that is normally, that means the substance is dissolved in water. But we can have any other solvent as well, right? So like I'm taking the similar example, the similar solvent I'm taking both the examples in the aqueous solutions. So what I get to see, if I just focus on the chemical reaction, that is the you can say the aqueous solutions, how they are performing or how they are acting towards the you can say the property what they are showing. If we just get into the deep, we'll see that the aqueous solution of NaCl do not allow electric current to pass through it, but the aqueous solution of sugar in water do not allow electric current to pass through it, right? So what is the reason? You know that any substance which want to behave as a good conductor should possess the ions, and the those ions should have the ability to move, right? So any substance, in order to behave as a good conductor, should possess the ions and which can move, or you can say they should possess the mobile ions, right? So what happens when this NaCl, as you know, is an ionic compound, right? So this is shown by almost all of the ionic compounds. Like I took an example of NaCl. This is applicable to almost all kind of ionic compounds, the aqueous solution of all kind of ionic compounds. So what we get to see in them, we see that when this kind of ionic compound is dissolved in water, so we know that ionic compound is already formed of ions. We know that it is formed of positive, Na is positive and Cl is negative. So when we dissolve this in the water, what happens? These ions just get surrounded by, you can say they just get surrounded by the oppositely charged ions present in the water, right? We have water in H also we have, and we have the oxygen also, right, which is negative. So what they do, these oppositely charged ions, as you are familiar with the geometry of water, you know that it is like that. So what happens? These ions just get surrounded by the oppositely charged ion of water. So that means Na gets surrounded by oxygens, many oxygen atoms, ions, charged ions of oxygen, and simultaneously the chloride ions get surrounded by many hydrogen ions. So what they do, that means these hydrogen ions or these oxygen ions surrounding the oppositely charged atoms, they just are capable of decreasing their force of attraction. And what they do, they just surround the oppositely charged ion, leads to decrease in the force of attraction, this positive and negative charge between the NaCl. They just help in decreasing the force, and they just make that the substance hydrated. And when they get hydrated, they are able to move freely in the solution. So this is, as I've told you, that any ion which has the ability to move free in the solution is a good conductor of electricity. So obviously now you can see they have the ions also, and these hydrated ions have the ability to move in the solution as well. So that means this is the reason that when aqueous solution of ionic compounds are good conductor of electricity, right? And when I consider sugar in water, what I get to see that we have water molecules. Suppose I am indicating this water molecules with the dark circles. So these are water molecules, right? And I am adding sugar to it. So what happens? Sugar just get dispersed in the water, or you can say it just intermingle with the water molecules, but do not get split into any kind of ions. So that means it gets intermingled in the water, but it do not get separated into specific type of ions. So that is why any substance, we know that any substance to behave as a good conductor should possess the free ions. So in this case we get to see no free ions. So that means it behave as a poor conductor of electricity, right? So my reason of telling you or explaining you these examples was that there are different kind of substances, out of which the two substances that is the electrolyte and the non-electrolyte. So any substance which allow electric current to pass through it, and which do not allow electric current to pass through it is called as non-electrolyte. So the substance which allow electric current to pass through it is an electrolyte, and the substance which do not allow electric current to pass through it is a non-electrolyte. As I've stated in the example, you can see the aqueous solution of ionic compounds all behave as an electrolyte because they possess, when they are dissolved in water, they possess the ions, hydrated ions, these ions are free to move around, and the movement of those ions only constitute the electric current, right? So that means they allow the electric current to pass through it, and they do not get dissociated into any kind of ions, or they don't show any kind of movements related to the ions. That is why it is considered to be non-electrolyte, that is the poor conductor of electricity, right? Now I think you are clear with the terms that whenever I'll be using the term electrolyte and the non-electrolyte, it will be just striking your mind that yes, the electrolyte is that which split into ions, it possesses the free ions, and those ions can move around freely and constitute the electric current. But when I talk about non-electrolyte, that means they do not dissociate into any kind of ions, and there is no such kind of movement shown by the ions. So that is why it behaves as a poor conductor of electricity, right? Now the question arises. So it is clear, I think, that in this chapter we will be considering only the electrolyte, because we need a substance which dissociates into ion, because when if the ions are formed, then only we will get to see the ionic equilibrium, right? So the question must be arising in your mind that yes, the electrolyte dissociate. So is it possible that all the substances dissociate to a same extent? Or you can say all this given amount of substance, suppose I have a substance of X concentration and B substance of Y concentration, say. So that means X will dissociate and Y will dissociate at the same rate, or we'll get to see the same number of ions? No, it's not like that, right? So the different types of substances have you can say the different ability to dissociate, right? Before we do that, I just want to make you clear that we often use word dissociation and ionization as one term, but actually it is not one. There is a lot of difference between the dissociation and the ionization. It is not the subcategory of this, it is a new topic, that dissociation and ionization is something different, right? So what difference we get to see in the dissociation and ionization? See, dissociation is that, suppose I dissolve a substance AB, right? I have a substance AB and I know it is an ionic compound, that means it already possesses the oppositely charged ions. It already has the ions in it, right? I'm not doing anything to create those ions. That compound already has the ions, right? So when this type of substance will be dissolved in water, what happens? Its ion will get separated. So this is called as somehow the dissociation. That means the substance already possesses the ions. So when we are just dissolving in the water having the high dielectric constant, or you can say the ability to just separate those ions, and it is just separating those ions. So we are not making those ions, that it already possesses that property that it has the ions. So it is called as dissociation, right? It is applicable in case of all ionic compounds, because all ionic compounds already possess the ions in the structure itself. And when we talk about the ionization, suppose I consider a molecule HCl. Right, you know that there is a covalent bonding, and in the covalent molecule there is no such kind of charge seen. But we know that if there is a difference of electronegativity, then the covalent compound becomes the polar or non-polar, right? But still they have the charge, but the amount of charge is too small. We say only partial positive and partial negative charge, but still we don't get to see this, you can say, the high magnitude of charges. So still we'll call it as polar covalent bond, but still it will not possess that magnitude of charge as it was possessed in the ionic compound. So what is going to happen? When I am going to dissolve this HCl into water, then water will just help in making them charged, and then they will get hydrated. That means on dissolving in water, they just the charges just appear. So that means they get ionized, because the charge was already not present, but when we dissolved in water, the charge arised, and then these ions got hydrated, and it becomes, or you can say it allows a slight amount of current to pass through it. So this term is called as ionization. So there is a difference between the dissociation and the ionization. Dissociation is that in which the compound already possess the ions, right? And ionization is that in which the compound do not possess the ions. It just gets separated into ions when it is dissolved in a given solvent, and in it the ions are already present, and when we just dissolve it, that solvent has a tendency to just separate those ions. So dissociation and ionization is one of the different things. So then don't just mix them up, right? So now we have is a new topic that will be starting now after knowing about dissociation and ionization. The question must be arising that I was talking to you earlier regarding that question, is that do all substances just dissociate at same rate or dissociate into the same amount? No, it's not like that, right? So we have degree of dissociation. Different substances have different power to get dissociated. So we call that power as degree of dissociation, right? So what is degree of dissociation? It is actually the number of molecules of electrolyte that get dissociated divided by the total number of molecules of electrolyte. Right. So degree of dissociation is that all the molecules of electrolyte may not dissociate or may dissociate. We don't know. It is different in case of different you can say the substances, right? So because the different electrolyte is considered to be a strong or a weak electrolyte. So depending upon that, we have the degree of dissociation, that is up to what extent it dissociates, right? So what is that? Degree of dissociation is just denoted by alpha. Right, it is a symbol used for the degree of dissociation. And what is that? It is equal to the number of molecules of the electrolyte that get dissociated divided by the total number of electrolytes, you can say the total number of molecules of the electrolyte which was present, right? So this is called as something the degree of dissociation. As I told you that different substances just dissociate up to different extent. So what are the factors that favor the dissociation? So the factors which favor the dissociations are, first comes the nature of solute, because we have the solution, so obviously we will be having the solute and solvent, you know that. So what is the first factor that is favoring the dissociation? That is the nature of solute. So depending upon it, we have two kinds of solutes, or you can say we categorize the solute depending upon its nature into strong or weak electrolyte. So what is it? Strong electrolyte is that which completely dissociate into ions, right? For example, if I say that if I take NaCl and I dissolve in water, what I'm going to see? I'm going to see Na ions and Cl ions. it will get almost dissociated into ions. That means we'll get to see only Na and only Cl, nowhere the NaCl will be present. So that means it is a strong electrolyte because it completely dissociates. The degree of dissociation is too high for it, right? But when we talk about the weak electrolyte, for example, I say acetic acid, what I get to see in that, I get to see acetate ions along with hydrogen ions. So at the end, what do I see in the solution? I see in the acetate ions, I get to see the hydrogen ions, and as well some unionized, this you can say the electrolyte is also present. That means it do not completely dissociate into ions. So that is why it is called as weak electrolyte. So coming to the point is that the substance which completely dissociates into ions is a strong electrolyte, and the substance which partially dissociates into ions is called as a weak electrolyte, right? So I think it is the first factor which is clear to you. The second factor that favors the degree of dissociation is that the nature of solvent. The solution is formed, you know that when we dissolve solute in solvent, then only the solution is formed. So that means the solvent also play an important role in the degree of the dissociation. How? Now the question is how? See, so the how, I am just telling you that how this thing serve as an important function is that the solvent actually has the ability to decrease the force of attraction between the molecules and get them hydrated so that they can move, right? So as we take an example of water, you know that water is a universal solvent. You know what is the dielectric constant of the water? You are familiar with the term dielectric constant. Still I am repeating for you. Dielectric constant, it means the power of the solvent to decrease the force of attraction between the molecules which are dissolved in it, right? So the water has the highest dielectric constant, that is the 80. That means it has the ability to reduce the force of attraction from the original force of attraction by 80 times, right? That is why it is a universal solvent, that most of the substances just get dissolved in it, because it has the power to decrease the force of attraction and just then make those ions just hydrated in it, right? So the nature of solvent, that means, also plays an important role. Like if we are dissolving any substances in water, that means the water has high dielectric constant, so that means it will get to reduce the force of attraction between those ions which is present in the molecule and will make them hydrated, and those hydrated ions can move, and you know that when the ions move, that means they constitute electric current. This is what the property of the electrolyte, right? So the second factor which favor is the nature of the solvent. One example is just striking in my mind is that, see, the aqueous solution of HCl is considered to be a good electrolyte because it allows almost all electric current to pass through it, or it just constitute the maximum amount of electric current, right? But when this solution is made, when HCl is dissolved in toluene, it hardly allows electric current to pass through it. So that means it behaves as a bad conductor of electricity in that case. So what we get to see in water, the water get to just decrease their force of attraction and make them ions so that they can move around freely. But in case of toluene, the dielectric constant is not too high. Its ability to decrease the force of attraction is not too high. So that is why it is not making the HCl split into the ions. So we know that when more ions are not formed, they will not move and they will not constitute electric current. So that is why it is the bad conductor of, or you can say it is a poor conductor of electricity. So that means the solvent also plays an important role in the degree of the dissociation, right? Because the solvent has a dielectric constant, has the ability to decrease the force of attraction, and if the solvent will decrease the force of attraction, then only the substance is going to get dissociated, right? So the third factor is dilution. What means dilution? Dilution means addition of more solvent into it. If we are diluting something, that we are adding more solvent to it. If the solvent is water, so that means we are adding water to it. If the solvent is toluene or something other than that, so that means we are adding more amount of solvent to it. That's it. So how the dilution increase the degree of dissociation? You know that any substance dissociate into ions when it is dissolved in a solvent. The aqueous solutions are good conductor of electricity actually, right? So that means the dilution will just, there will be more solvent molecules and they will just get to decrease more force of attraction and more ions will be formed which will constitute the electric current. So that means on dilution the degree of dissociation is definitely going to increase. So this is the third factor on which the degree of dissociation depends. Next factor is the temperature. As we will increase the temperature, you can say the degree of dissociation will also increase, because the ions will tend to move farther from each other, because we know that the temperature just increase the kinetic energy of the molecules. So when we will just supply it with the temperature, when we will supply it with the heat, they will gain that heat and they will start moving faster, and which will lead to the decrease in the force of attraction between them. And when there is decrease in the force of attraction, that means more ions will be formed, right? So this is how the temperature increase the degree of dissociation, and vice versa. If we decrease the temperature, so obviously degree of dissociation is going to decrease, right? And the fifth factor which just affect the degree of dissociation is that addition of some substance. Sometimes few substances when added to a given electrolyte just suppress the, you can say, the dissociation. They just don't allow more ions to be formed, right? And this is somehow called as common ion effect, which we'll be taking up later. Again, I'm repeating you, sometimes when we add certain substance into an electrolyte, what they do, they just suppress the electrolytic dissociation. And those electrolyte which when added to a given electrolyte suppress the dissociation, the phenomena is called as the common ion effect, and the reason we'll be taking up in a detail in a later as in a topic, that is the common ion effect, right? But and the few substances which just increase the, you can say, the dissociation, they are affecting the degree of dissociation as they are increasing the degree of dissociation. So that means the degree of dissociation might increase or decrease depending upon the substance or an electrolyte which we are adding to a given electrolyte, right? So these are the 5 factors on which the degree of dissociation just depends. I think it's clear that for an electrolyte to behave as a good electrolyte, there need to be formation of ions, and those formation of ions, that means the number of ions which are formed actually is called as degree of dissociation, and it depends upon the nature of solute. On the basis of that, we have the strong electrolyte and the weak electrolyte. Second is the nature of solvent, because solvent is very important because it is a factor that is just decreasing the force of attraction and making them split into ions. So that means the second factor is also playing an important role. Third is the dilution. The second and the third factor almost you can say they are similar to each other, because the nature of solvent means the ability to decrease the force of attraction, and if we'll have that factor more, it will decrease the force of attraction obviously in a great manner, right? Next is the temperature. As we know that the motion is just a factor of temperature, that means kinetic energy somehow depends on the temperature. So as we'll increase the temperature, the molecules will gain that energy and they will start moving with a greater force, and when they will move, they will just break their original forces, right? So that means they are going to split into ions, more ions will be formed. Last, addition of substance, that matter that what kind of substance we are adding to it, because we come across different kind of substances. Some increase the degree of dissociation and some decrease the degree of dissociation, and the one which decrease the degree of dissociation are mostly those electrolyte which contain the common ion, which we will be taking up under the common ion effect. So I think it's clear that what is the degree of dissociation. Now we'll be going to start with the new topic, because you are familiar with the electrolyte and you are familiar with everything. Now there was a scientist, that is Arrhenius. You must be familiar with Arrhenius. So Arrhenius just gave the theory that is based on the electrolytic dissociation, that how the dissociation occur. So Arrhenius just stated his, just conducted an experiment and stated his observation in the, in the theory, that is the Arrhenius theory of electrolytic dissociation.